Mid-segments.
But do you want me to excuse that?
Yeah.
Okay, sorry.
Just for you. All right, triangle mid-segment theorem. So you have one more type of segment to learn about. It's not as complicated as the other segments, so in fact, I think you'll find today pretty straightforward. Triangle mid-segment theorem. And a mid-segment connects the midpoints of two sides of a triangle. The mid-segment connects the midpoints of two sides of a triangle. Michael, you need to put your head up now, please, and participate. Please and thank you. Mid-segments connect the midpoints of a triangle. And every triangle has three mid-segments that can possibly be constructed. Because there are three sides on the triangle. So again, you can find midpoints on all three sides of a triangle. So I'm just going to sort of eyeball it here. Okay, so this midpoint over here, I'll call that A. That cuts this side in half. I'll call this midpoint B. That cuts that side in half. C cuts that side in half. All right? If I connect the midpoints to each other, so these are not medians. I'm not going to connect the vertex to the midpoint. It's going to work a little bit different. And if you're in my second and fourth hour classes, we did a project like this already. If I connect my midpoints together, so if I connect A to B, that's what a midsegment is. A midsegment connects two midpoints together. And I can connect B to C, and I can connect A to C. Now, what does it look like happened? Kind of. Like, what do you see here? Any observations that you see? Okay, made a smaller triangle inside of it, absolutely. What else do you think? Any other observations? What'd you say? How many congruent triangles do you think there are here? 4. Yeah. So it kind of cut the original triangle into 4 congruent triangles. Yeah, you guys are exactly right. So Savannah kind of saw it as like the big triangle almost being like shrunk into this green triangle, which is similar to the original triangle, just smaller. It's like it got reduced and then twisted around. And then Luke kind of saw it as being cut into 4 equal triangles. You're exactly right. And you could continue that process forever and ever and ever and create something called fractals, where it would keep creating smaller and smaller and smaller triangles that are all similar to the original one. Very good. So you're exactly right. It is creating 4 equal triangles here. So like this side here, AC, is going to be equal to this side cut in half, essentially. And this side here, AB, is equal to this side cut in half. So one of those halves. And then this side is equal to this side cut in half. And that's where we're going with this stuff today. So mid-segments, triangle mid-segment, now they're only using one to kind of show this theorem here. Connecting midpoints of two sides is always going to be half as long and parallel to the third side. So whichever two sides it's connecting, it's going to be parallel to the third side, or the one that it actually looks parallel to, and half as long. So for instance, if AC is 10 units long, DE is half of that, 5 units long. And again, if I go back for a second, that kind of goes back to what Luke was saying about having it be a bunch of congruent triangles. If this whole side is 10 units long, that means half of it's 5, and that piece would be 5, creating all these different little congruent triangles inside. All right, so pretty easy here. Number 1, if you are looking for the length of D to E, let And I'm just going to go ahead and call popsicle sticks here because I think this is pretty straightforward. It's parallel to BC, meaning it's half as long. So Faith, how long would DE be? 14. Very good. Okay. Number 2, we're looking for the length of BC. DE is the mid-segment. Tristan, how long do you think BC would be, or thoughts on how to find BC? BC, 30. Okay. So you'll notice he did not say 7.5. You're not going to cut 15 in half because 15 is the mid-segment length. That is the segment cut in half. So if you're finding the full length, you would double it. So just use your common sense there. If you're finding the bigger one, double it. If you're finding the smaller one, cut it in half. Now, 3 is a little bit different because it's not asking about the mid-segment, but remember, mid-segments are created by connecting midpoints. That means E is a midpoint of that side of the triangle. So if E is directly in the middle of that side of the triangle, then Tarek, how long would E to C be?
21.
Hilarious. E is a midpoint. What does that mean? Okay, so 9 and say with confidence.
Oh no.
What'd you say? There shouldn't be any calculator involved. This is half the segment. This is going to be the same half, same length.
Right. You said 9.
Oh, I didn't hear you. I'm sorry. Okay. Very good. Question so far? Pretty straightforward. Now, when they give you multiple side lengths or multiple mid-segments inside of one triangle, you just want to make sure you understand it's always half as long as the side that it's parallel to. So this question asks you to find the perimeter of DEF, which we currently don't know any of the sides of DEF, but we can easily find. Let's start by finding the length of DE. Now, what side of the triangle, the original big triangle ABC, is DE parallel to? So is it parallel to AB, is it parallel to BC, or is it parallel to AC? And Ada, which side of the big triangle would DE be parallel to? BC, very good. So we're not just going to cut any of the sides in half, we're going to specifically cut 45 in half. And you will get a decimal there because it is odd, and that's okay. So 45 cut in half, anybody? 22. Thank you, Ashley. 22.5. So DE would be 22.5. Okay, let's go to EF next. EF is parallel to what big side of the original triangle? Caitlin? EF is parallel to what original, like what side of the original triangle? AB. So if AB is 13, cut 13 in half. Anybody? 6.5, thank you. And then finally, DF is parallel. Jacob, I know there's only one side left over, but I'm going to ask anyway, is parallel to what side of the original triangle? DF? AC? So it's half as long as AC and 38 cut in half. Anybody? 19. Very good. Now, the final question says find the perimeter of the little triangle DEF. Perimeter of the little triangle DEF. So, Lakin, how could we now go about finding the perimeter of triangle DEF? Okay, adding what together? 22.5, 19, and 6.5. Very good. 22.5, 19, and 6.5. And Aaron, let me know what you get when you add those 3 together.
88.
Very good. Questions so far? Not too challenging, I'd say. Okay. Let's do at least one graphing one. You might not get to the second one. That's okay. You will have, I think, one or two problems like this on your homework. It says, in triangle JKL, show that midsegment MN is parallel and that MN is half as long as JL. So what you are essentially doing here is you're going to use slope and distance to prove MN is a midsegment. So you're not solving for a distance necessarily. You're not solving for like a specific answer. You're just using your work to prove MN is a midsegment. So let's start with the first part, parallel. How could I go about proving that MN is parallel to JL? Well, parallel lines, what's true about the slopes of parallel lines? Who can raise their hand and tell me? True about the slopes of parallel lines, Michaela? Very good, they're the same. So if I can just show and prove that the slopes are exactly the same, I will have proven that they are parallel to each other. So let's first calculate the slope of MN. Not because I have to do MN first, I just saw MN first. So MN, first of all, is that positive or negative slope? It is negative slope. Okay, we got to get that logged into our brains before next year. MN is falling from left to right, so that's negative slope. And rise over run. Rise over run. So in this case, fall over run, I guess. But Connor, how far down did it go? 1, and how far over did it go? Good. So it has a slope of negative 1 over 4. Okay, I want to prove that JL has exactly the same slope. So from J to L, it's definitely negative. That's a good sign. And Adam, can you count the rise over run from J to L, the original rise over run? So how far down and how far over it went for me? Very good. Negative 2 over 8. Which isn't exactly the same as negative 1 over 4, except negative 2 over 8 reduces. What comes out of both 2 and 8? 2, leaving it at 1 over 4. Very good. Okay, negative 1 over 4, negative 1 over 4. That proves they're parallel to each other. And now I want to prove that MN is half the length of a JL. And here's where it gets just a little bit more complicated. Okay, not complicated, just takes a little more time. So we're going to find some distances here. Let's start with, again, with the distance of MN, the length of MN. Now, you can choose to do distance formula if you want, except the coordinates aren't written out for M and N. Or we can do that little Pythagorean theorem. We've done this a few times this year. So we can drop a right triangle in right here from N to N, almost like we're doing slope again. That distance is 1, that distance is 4, and we can do a little Pythagorean theorem, a squared plus b squared equals c squared, to solve for the length of MN. Right? We did that a few times first semester. So I've essentially just used the slope to set up a little right triangle, and now I can do Pythagorean theorem. A squared plus b squared equals c squared. One squared is 1, 4 squared is 16. One plus 16 is 17. Now, when we square root here, we're actually going to just leave it as a radical instead of getting a decimal. I'll show you why. When we square root, 17 doesn't reduce, so MN ends up being exactly the square root of 17. Okay, we're just going to hang on to that number for a minute. It's not like an answer to the problem or anything. We're just hanging on to that number. Now we're going to find the length of JL. And we're going to prove that JL is exactly double the length of MN. So again, we're going to use kind of like our little slope to set up a right triangle again. We went down 2 over 8. So a squared plus b squared equals c squared. 2 squared plus 8 squared equals c squared. making a very poor life choice, not writing this down. 2 squared is 4. 8 squared is 64. Very good. 64 plus 4 is 68. Okay, square root that. Now, it's going to take a little bit of a review here. The square root of 68 you guys remember those little factor trees from last year in Algebra 1? What two numbers multiply to 68? 2 and 34. 34 breaks up into 2 and 17. Circle the pairs. The pair comes out, and the single stays inside the radical. And it ends up being 2 radical 17. Now, the reason why we like to keep them in exact form is because now you can prove that JL was exactly double the length of MN. Exactly double. Radical 17, 2 radical 17. Now, let's just go to our calculator for a minute. And I'd be okay with you using decimals. It's just you have to round it, and that's the only reason I don't really like it. But if we type in radical 17, we get like 4.1-ish. So when I type in radical 68, it should be something close to 8.2. Something close if I do this right. So if I type in radical 68, it comes out to be about 8.2, which is fine as well, as long as you understand that it might not come out to be exactly double because you are approximating. If you leave it exact, it comes out exactly double. If you round, maybe it's double, maybe it's off by like a tenth, but should be pretty darn close. Okay? So in a problem like that, you're not actually solving anything. You are just using work and using mathematic calculations here to prove the fact that it's a midsegment. Okay? I'm going to skip the second one because I'm going to make sure you have plenty of work time today. I know for a fact I shortened your homework. I know for a fact I did and only put one problem like that on there because I took off the second problem. You're welcome. All right. Last little problem here just says triangles are used for strength and roof trusses. In the diagram, UV and VW are mid-segments of triangle RST. Find UV and RS. This always reminds me of like back in elementary school, we had to do a project with like toothpicks and marshmallows and like whoever could build the strongest bridge. Our team always lost because apparently triangles were like the strongest support system and we didn't know that. We were making like giant rectangular tube things. Anyway, long story. All right, find UV and RS. Let's start with UV. Okay, UV is a mid-segment. It's going to be half as long as the side that it's parallel to. So, Aaliyah, what side is parallel to UV? Parallel. Say again? RW, RT. Okay, so UV is half as long as RT. And Aaliyah, what's half of 90? RS is the entire side length of the big triangle. So RS is parallel, Anthony, to what side? VW. And if VW is 57, then Anthony, how can we find R to S? Double it, and what's double 57, Anthony? Good. Okay. There are some questions on your homework that involve like a lunch tray figure. And it asks you just simply like which side is parallel, it's half as long as which side, so on and so forth. Or it's congruent to both sides, okay? All right, that gives you about 15 minutes to do your homework. That's kind of where I want it to be so that you had time to work and ask questions in class as we kind of get back in the swing of things here. So make sure you get started.